Okay, in Lesson 8.6b, we're going to answer two essential questions. How does shifting data affect the mean and the median? And how do I choose the appropriate measure to summarize a set of numerical data? So let's take a look at workbook page 335. Compare the dot plots below. Plot A has a line of symmetry. The data in plot A are symmetric because the shape of the data on one side of the line of symmetry is the same as the shape of the data on the other side of the line. So if you look, you can see the line of symmetry. Let me get my pen moving. You can see the line of symmetry here. It's that line with the arrows there. That's our line of symmetry. It's cutting it right through the middle, and we have the same number of dots on each side. We've got 3 dots on this side, we've got 3 dots on this side, and the center has 4 dots all the way through. If you look at plot B, it has the same number of data values, so it still has the same number of dots there. But when compared to plot A, you can see that some values in plot B have shifted to the left. Take a look at these 3 yellow dots here. You can see that instead of them being over here, they were shifted down to the left side. So now they're over there. What we're going to do is we're going to calculate the mean and the median of plot A. So we're going to focus on plot A right now. We'll worry about plot B later. So let's start with the mean. We have to add all of our numbers up and then divide by how many we have. So let's see, I've got 13, I've got 14, 14, 15, 15, oops, erase that. Alright, so we've got 4 15s, and then we've got 2 16s, and a 17. So what I'm going to do is I'm going to add all of those numbers up, and I am going to get 150 when I add all of those up, and then I'm going to divide by 10 because there are 10 data values here. So 150 divided by 10 gives me a mean of 15. And now what I'm going to do is I'm going to find the median. And remember, the median is when you locate the number in the center. So I'm going to cross them off, remember, going left, right, left to right, left, right, left, right, left, right, left, right. And it looks like I've got 2 numbers in the center. I've got 15 and 15 in the center. So what do I do if I have 2 numbers? Well, if it's not obvious what the center number is, you can find the mean of those 2 center numbers. And that means adding them up and dividing by 2. 15 plus 15 equals 30. Divided by 2, guess what? It looks like the median is also 15. Now for number 9, plot A is a symmetric dot plot. How is the line of symmetry related to the mean and the median of the data? So remember, the line of symmetry went right through the middle. What set of dots did it go through? Well, it went through all the dots that represent 15. So in this case, the line of symmetry represents the mean and median. Okay? Let's move on to the next number 10. It says, using words, predict how the mean and the median of plot B may be different than the mean and the median of plot A. So this is your own response. What do you think would happen to the mean and the median if we start looking at plot B now? So remember, the mean over here was 15, and the median was also 15 over here. Do you think that would be the same in plot B? Now we're going to find out. Look at number 11. Calculate the mean and the median of plot B. Was the prediction that you made in exercise 10 correct? Well, I don't know what your prediction is, but we can at least calculate the mean and the median of plot B. So let's see. We've got 12, 2 13s, 3 14s, and 4 15s. And what I'm going to do is I'm going to calculate the mean by adding them all up and then dividing. When I add them all up, I'm going to get 140, and then I'm going to divide by 10 because I have 10 numbers, and 140 divided by 10 is going to be 14. So the mean is 14. Now let's figure out the median. So left, right, left, right, left, right, left, right. And it looks like I have two numbers in the middle. Again, this was an even set of data. I had 10 numbers. So yep, I'm going to have two numbers in the middle. And again, if you can't figure it out by looking what would be in between 14 and 14, you can find the mean of those two numbers. You can add them up and divide by 2. And that's going to give you 14. So the mean was 14 and the median was 14. Is that what you thought would happen? The last thing, number 12, why do you think the shift of dots to the left, as is shown in plot B, decrease the mean and the median of plot A? So why do you think shifting the dots to the left made the mean and the median go down? Well, shifting values to the left decreases the values and decreases the sum of the values. So if you're decreasing the values, if you're making the numbers smaller, when you start to work your way to the middle, you're going to have smaller numbers in the middle. And remember, for mean, you have to add them all up. So if the numbers have decreased, well then when you add them all up, that sum of the values will also have decreased, causing your mean to be smaller. Now let's look at workbook page 336. Same idea. We've got two dot plots. Plot A, again, you already know. We saw that before. Now we're going to look at plot C. We're going to calculate the mean and the median of plot C. So let's see here. We've got 13, 2 14s, 3 15s, 16, 17, and then 18 and 19. So what I'm going to do first is I'm going to add them all up so that I can get the sum and divide that by the number of numbers. And I'm going to get a sum of 156, and then I have to divide that by the number of numbers, which again, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to divide by 10. And the mean, oops, I'm putting that in the wrong spot. The mean is 15.6. And now for the median, let's see, left, right, left, right, left, right, left, right. And what would be in between 15 and 15? Well, again, you can add them up and divide by 2, or you might be able to recognize that the median is actually 15. So in this case, how did the shift of dots to the right, as is shown in plot C, affect the mean and the median? So if you look over here at plot A, they took this dot here, this yellow dot and this dot, and they moved them over to the 18 and the 19. So they shifted some of the data down to the right. How did it affect the mean? How did it affect the median? Well, the mean increased, but the median stayed the same. That was still 15. Why does a shift to the right increase the mean? Well, shifting to the right increases the values, which increases the sum of the values. So remember, you have to add all of these numbers up before you divide. Well, if your numbers are increasing, if you're shifting from a 15 and a 16 over to an 18 and a 19, the sum of your numbers is going to increase, meaning when you go to divide, you're going to end up with a bigger mean. All right, now we're going to jump over to page 338. We are going to talk about when it's best to use the mean or the median. Okay, it says, estimates of the populations of 7 cities in Colorado are shown in the table at the right. The populations have been rounded to the nearest 1,000. We're going to calculate the mean of the data, and then we're going to find the median of the data. So let's start with the mean. We have to add all of these numbers up, and you know what? I think what I'm going to do is I'm just going to use this table here for my addition. And I'm going to end up with 168,000. And then I have to divide by, let's see, 1, 2, 3, 4, 5, 6, 7 numbers. So 168,000 divided by 7, that's going to give me a mean of 24,000. Now we're going to find the median. Now remember, we have to put our numbers in order from least to greatest or greatest to least. It doesn't matter to me. So let's see, we've got a 16,000. I might just do the 16 instead of 16,000. 16, and then we have 1, 2, 3, 4 17,000s. And then we have an 18,000. And then it looks like 66,000 is the next one. And there's 1, 2, 3, 4, 5, 6, 7 numbers there and 7 numbers here. Perfect. So remember, I'm going to go from left to right. So left, right, left, right, left, right. And it looks like the number in the middle is 17. So 17,000, remember that 17 was representing 1,000. 17,000 is the median. So we've got the mean, which is 24,000, and we've got the median, which is 17,000. How could you summarize the populations of all 7 cities using only one number? Would you choose the mean or the median to summarize the populations? Give a reason to support your answer. So let's see. It looks like we have, 16, we've got 17, several 17,000s. We have 18,000, and then we have that 166,000 in Loveland in Colorado. That must be a really big city. There's a lot of people there. That sounds like a lot of people. That I would consider to be an outlier. When I talk about an outlier, I'm talking about a number that is either really big or really small compared to the rest of the data. 66,000 is really big compared to the 16, 17, and 18,000 that we see in the other Colorado cities. And take a look at what that 66,000 did to the mean. Because of that high number, the average, the mean, was 24,000. We're saying the average population for the city, for those different cities, is 24,000. That doesn't quite seem right, considering all the numbers are mostly 16, 17, and 18,000. That 66,000 increased the mean. It caused the sum of the numbers to be greater. The median, though, that seems a little more accurate, 17,000. Well, most of the numbers were 16, 17, 18,000, so I think the median would probably be the better way to summarize the data. The mean wouldn't work because of that 66,000 outlier. So let's see. The median would best be used because of the 66,000 people outlier. That outlier increased the size of the mean. So I think the median would be better because of that outlier. If I didn't have that outlier there, if that was like 18,000, 19,000, 20,000, even 14,000, 15,000, it seems to go closer to the rest of the numbers, then I would say maybe the mean would have been more accurate. But because of that outlier, the median would be the best way to go. Okay, so here are your takeaways. We talk about symmetric data, which is a data distribution that has a line of symmetry. and the shape on one side of the line is the same as the shape on the other side of the line. And then I talk about what happens when the data shifts to the left and what happens when the data shifts to the right. So when the data shifts to the left, the mean and the median could decrease. And when it shifts to the right, the mean and the median could increase. And then this one's really important. Which one is best, mean or median? Well, mean is typically the best one to use when there's no outlier. However, if you do have an outlier, like that last problem that we saw with the populations of the cities in Colorado, when you have an outlier, the median is probably the better way to go.